Hello, everybody. Software development is full of axioms and rules that are sometimes expected to be self-evident. We are taught from the first days of our professional education that there are right things to do and wrong things to do. We are trained to reuse, to encapsulate, and God forbid not to reinvent the wheel. And I want to tell today a little bit of how maybe deviating or even breaking some of those rules could be beneficial. My teammates and I, during the last year at Fireblocks, we decided to develop absolutely from scratch without anything other than the standard C++ library, JSON schema validation and serialization tool, which I hope sounds to you as insanity. That's the premise of the whole story. And I want to tell how we use that to improve different processes and benefit from this library beyond the question of JSON serialization itself, which is great by itself. My name is Yaniv Mordekhay. I'm a software architect at Fireblocks. And to understand the story, I must introduce the company, because this story is basically a story about much more about human communication rather than technology. So the setting is very important. So Fireblocks is a young, around 6 years old Israeli startup, very successful fintech company. We serve over 100 different blockchains, have integrations with 350 of the largest financial organizations in the world. We have currently more than 250 wallets that we serve to our customers, and we passed already more than $6 trillion worth of transactions. So, like, really best possible probably story for from like success with customers that could be for a startup. But as you can imagine, to process all that data and all those operations requires special ability to scale, both in the technology and in the workforce, because you cannot continue with like 12 people to manage all this development and operation. And that's where our most challenges are. And I guess most of you know how it goes. A company starts with a tightly knit group of developers that are all like the best in the field, do everything, and they are very well aligned with each other. They sit in the same room, and they practically share the same vision and the same idea without even talking. The green thing, it's my artistic impression of same idea being shared by people, so I'm sorry if that's not clear. So, and things go well. At this stage, of course, the customers and investors and all that is by far more important than anything else, because no use to write code if you close the company next month. So this is the right thing at these stages, not to think too much about how the information is shared and where it all goes. And the company grows. and probably there are multiple floors and more rooms. It's not one room already, so there are more teams, and each team starts to get its own color, a little bit of its own culture, and maybe some development practices until, like, if it's a success, when then we reach this stage. That's where Fireblocks is now, because other than developers in Israel, we have developers in Australia, in the United Kingdom, in the USA, and in Serbia. So it's not a matter of like, it's too far to cry to the other side of the floor. It's like, it's humanly impossible to cry loudly enough so they will hear in Australia. So when someone in Australia doesn't know how to do something, he cannot just, walk the corridor from like one side to another, ask people around. He like sits with, I don't know what they have there in Australia, with the kangaroos and like that's the best he can get. And that's like key moment in any company. It's not something special at all. It's not even bad because it could be a very great diversity where different teams with different cultures inspire each other. All these teams could become islands that have moats around them and no bridges. And at this stage, it becomes much more important to invest in proper communication in the organization rather than adding another customer number 3,000. As important as it is, if the development team cannot implement what the product needs, then the company won't be able to grow. So I want to discuss at this pivotal moment, how can we do what we do best to actually affect, to better the situation. And the best we can do is to write code. And my claim is that, first of all, code is mostly communicating with other developers. And it's not really for the machine, as some might think. And it's easier because it's a formal language, right? It's not natural language. So we kind of better because we have spec and we don't get anxious that we need to generate live all the thoughts into a language without a clear specification. I don't remember what is the next slide. Oh, okay, now I remember. So the symptoms, these are not, it's not like a problem by itself. But these symptoms, they're signs of a struggle that needs to be addressed somehow. So if it becomes very difficult to get answers. If you find yourself making rounds in the corridor and asking 20 people how to do something, if it seems like people do not have the resources to think and plan and innovate and are just in perpetual mode of crisis solving. And if you come to junior developers and ask them about a problem and they just seem kind of all right with it by avoiding or denial, that's the best symptom, because we do not want to struggle, right? We do not want to come to our workplace, especially to leave the daily struggle. So each one copes somehow. And the less tools a person has professionally, the more you will need to use psychological tools to cope with the situation. Because everyone wants to come to his workplace and like do his job well and return home happy. And people will get to that situation this way or another. We just want them to reach to that feeling without tools like denial and avoidance, right? So what we do in the situation, I'm cutting quick to code because I was told that talking to C++ developers for more than 5 slides without code is no one will sit in and will go away. So okay, so we had like obvious reasons without all the philosophy why we actually wanted a technical solution. I'm talking like really like give me a library. JSON is a ubiquitous thing. 20 years ago, to think that in C++ code we will deal with all those endless strings was unthinkable. Now it's everywhere. And we had from day zero JSON library, which is great, works perfectly, no problems at all. And as long as there wasn't like a lot of code around it and the structures weren't that complicated, it worked pretty well. But gradually the validation code started to kind of interweave with the like logic itself, and here like I just pasted the real snippet that it's a good code. It doesn't work. There are no bugs, but it's really difficult to understand from it. Like if it's your external interface, it's really difficult to get to this point and understand what goes on here. Like what are the requirements of this data structure? Other problem is that this approach doesn't really force you to do the validation well. Like usually the code looks like I think that it will be nice to check that I have these properties and that properties, but that property I'm quite sure that is always there, so I won't write another exist because it's tedious in long JSONs to write exists this, exists that, exists that. So the validations, they are not like the same, and you never know where it is checked well and where it isn't checked at all. And of course, if you come to an existing code and you want to understand what is the interface, from this code it's really difficult to understand that. And it's even more difficult to test because the logic, the decision to go and write from scratch such a library is not trivial because like if you come to me and say I'm going to write such a library, I'll just like laugh in your face probably because it's like endless features. 100% probability of very difficult to find bugs, and it's not like it's not my team's job. Like we write business logic. We're not like infra or something. We had a task, and that like it wasn't our plan to write this library, and of course we never have time for detours like that. And the key to this thing is to think differently about what we want to achieve. because it's very common for developers to not differentiate between a tool and a goal. So the goal isn't really a JSON schema serialization library. The goal is to have something that is very compile time validated. We want like abstraction of JSON underlying JSON library. As a matter of fact, we don't care about JSON because like we want to ensure some structure. Maybe it's not even JSON. We want serialization in both directions, of course, we just want to write our regular classes without some boilerplate thing, or like it should be perfect miracle. Here is a progress bar to real C++ code. I'll send here, so we'll see how many slides left. The idea here is to define to ourselves like what are our like the ultimate desire, so when we meet the reality and decide what are the compromises, we know that they are compromises and not that we kind of started with the compromises, because when you think about these items by themselves, many answers to them could be much simpler than just write JSON schema serialization library, which sounds scary. And in a moment, I will show you what I mean. And we do not want to like write extra code. So the way I go about it, do I have time? No. Okay, I just let it like live in my head in the background for like sometimes for months. Like I really work on kind of mindful approach to like cleanse the idea from the context of my day-to-day life and let it sometimes just not think about it at all, like forget about it until it reminds me that there was some background process that somehow reached some conclusions. So, okay, let's talk about code. It will be much easier. This is what I want to like show example that we are fintech company. So I just took some definitions that we have. So we have it's like the simple data structure of 3 objects that hold like members that are nested one inside another. And the idea is that we just have this struct, but it can be class, and there is 0 anything that is not like vanilla C++. No libraries, no like everything standard. We run kind of C++ 17, so like whatever is there, we use it. So this is our class that we want the miracle to happen and to be able to read a JSON and to write to JSON and without affecting this code. For that, we define a schema class. And I want to draw your attention that it's everything like it's defined in C++. So everything is compile time validated and is very explicit. And it's very non-functional. It's imperative. the library will actually like run this code line by line as any other code without some weird functional things, and you can put a breakpoint there and you will see exactly what is the JSON that you have, and how these properties are read into into those fields. So there is magic, but there is no magic. Really, it's really straightforward, regular C++. I just pass to it the object, and there is something that it should really feel stupid, and that's the whole idea. Anything other than that is just more complicated ways to read not text but object or array or one-off or any-off, because those are supported too. Also notice that this schema is bidirectional. You define it once and it works in both directions. So you don't have to keep separate definitions of how you write to JSON, how you read from JSON. And if you have some special logic that somehow doesn't map exactly one property to one class member, it's okay, because it's a regular code. You can put here some if or some, I don't know, as complicated as you choose. It's really user's decision. Of course, we'll always prefer it to be simple like that, but there are situations when JSONs change and we want to adapt it to existing classes, and then it's okay to maybe pay the price of more complicated code, but it will work fine as well. And another side effect of it is that it's really, really trivial to write tests for these things, because it's symmetric. All the tests, they always look just, you get an object and you create JSON from that object, and then you read that JSON back and check that you get the same object again. So there's really close to zero logic that you write in tests. So it's really becomes a non-issue. There is no reason not to write this test. Okay, so the basic structure, I have no time at all. Okay, so the basic structure is that we have that schema object that you saw, and we have the struct is there is the DTO, that for this DTO we define its schema that inherits the Jessica schema. That's the name of the library. And what you didn't see there is the serializer, because serializer is not connected to schema at all. You can feed it any serializer, and you will see the interface. It has interface. As long as you define this interface, you can write YAML, you can write JSON. It assumes it's something hierarchical, we already saw usages that were absolutely not planned initially, like, for example, code generation. We have a POC of code, a serializer that takes a schema and generates from it C++ code. So it's really, as long as you follow the messages. Okay, so here is how the serializer is connected in practice to the schema. And I'm running a little bit quick because I'm running out of time. Okay, so here's an example of object, which is actually like it's reusing the same like principle inside itself, because all this thing does is actually what there is the same principle that all this class does. There is somewhere this schema, and it just like calls the schema function of this thing inside. So there, like this function is like 2 lines of code. Okay, so one of I think I'll skip the technical details of how it works. Just I'll tell like the headlines. How do I go back? Okay, first of all, there is one of that works with a variant and knows to serialize and deserialize it, and I'll show you example of how it what happens when there are errors. And this is the serializer itself. So as long as you define, you do not even have to define all these methods in practice if you do not expect the serializer to support this feature. And you can see here that we have design decisions that were like very tailored to our needs. For example, all these variants of rational numbers that are sometimes a string, sometimes as numbers. So, and that's one of the advantages of this approach, that you really go with what your organization needs the most, and continue from there. So it's not like a huge undertaking in practice. Actually, like the first version that actually could use took like 3 days to write from the moment that we decided that we're going for it. And all in all, I think that we invested not more than a month, 1 month of a person during a year that this thing exists. So these are the writers. I want to get to, it explains the idea behind the one-off. It uses folding of template packs. It uses this principle that when you give several types as a template pack, you can expand it to this expression. So actually, one-off is very simple. One-off is very simple because it just creates this expression that serializes each time one member the same way it serializes like a whole object. Okay, these, I'm almost out of time, but this is probably the most important thing for me. That the thing that is was very central to the development of this library was that we prioritize user experience to the extreme. That means that we preferred to write internally code that breaks some software development concepts. For example, all these methods, there are protected methods in schema, which is a not good thing, because extending it is a pain, because everything is in the same place, and you need to jungle it. But if we're thinking about someone in Australia that needs to use it, like the other option was to create a different small class for each type. and then you have just, you add these classes indefinitely, and you can extend whatever. But we wanted for the developer to face this list in an unavoidable way, that he just cannot use this without seeing with his eyes the list itself. So he doesn't need to look in directories or read documentation. He cannot pass this thing, because that's the way he interacts with the library. So we preferred this very explicit way and inconvenient for developers of the library way to do it, but give a much better service to the users. It's extensively documented, has a lot of examples, and actually first usages of this library outside of like those who were part of the process and for them it was written, were like, we didn't know that it happened. I just one day I got a question like, do you know if Jessica supports this and that? Okay, we can meet and I'll explain. No, we're already using it. I just wanted to know, and it was like the best compliment probably, that like 0 questions asked. We knew nothing about it. And these are the errors. The errors too, they are like for us part of this exceptional experience that we want to give the developers. So it really generates, like if it's one-off and there is an error somewhere like inside the structure, you will actually see this error that actually tells you that I went to both variants didn't work. One didn't work because there was missing property, other because there was like some wrong values, or in this simpler example, an array that item 0 wasn't an object, while in schema you defined it as an object. So like really you can get exactly to the point inside that JSON and know what went wrong. And it's all like inside the exception that it throws, and there are standard way to write it. And this is a real quote from Shakespeare. I'll just run ahead. You are invited to talk to me. I can talk about it like endlessly. Okay. So like we don't have time. Yes, so I'm ending, and that's the last thing I just wanted to say. That the most important thing is to imagine really well where you want to get. Just don't think about the tool. Think about like the goal itself. And as I said, it took us 3 days to bring that up after we let it for a month to sink in our heads. And thank you, and catch me around for questions or something, because we don't have time. Thanks.